Let's go. Yeah, it's the four of us once again. Mr. Bush Whisperer Shaman there. We got Penelope in the background. Zhenya and I, Brian. And of course, welcome back to Portal Mountain Development Meeting number, I believe we're at number 60 right now.
Jesus.
And it's a long ways going. The last meeting, we basically were discussing
The APS
language, APS language stack, if you will.
Yeah.
Trying to get from the nitty-gritty archetypal stuff up into the kind of superfluous domain languages themselves, so that we can talk about how to program behavior, essentially, and not in a Borg sense,
Right.
But in a sense that when we know how to speak about actions and behaviors and environments, we can share how we can share and work on evolving our behaviors in a more regular fashion.
Yeah. In other words, I would say this is like we're not moving away from talking about how representations are not what's being represented, but at the same time, we don't want to say that representations don't have utility, right? And we draw that conclusion from the fact that biology is basically articulated in our world in such a way that whatever's inside the organism is a kind of a reflection of the outside of their environment. So that's why you will see an organism adapted to a particular space. And
does that work? I think it doesn't work. We might have to restart. Oh wait, what? It does work that way? Okay. So
we're cool.
Yeah, so YouTube, they've intuited that I wanted to live stream even though I didn't start the stream here. So, of course, apologies for the noise and all that, but this is the way it is.
We are in a shop.
The way it is sometimes.
It's part of the input. It's part of the organic flow of the show.
Mm-hmm. That's right.
So
get this shared.
Right. So the point is that we're not shying away from the representational articulation. We're simply saying that, unlike taking it for reality itself, like as an ontology, we are declaring them to be more like a useful set of tools to be utilized as appropriate. Right? And because of that, we want to have...
You mean representations in general?
Yeah.
To be used as a tool? Yeah, sure.
And on top of that, we want them to be as meaningful as possible that reflect the inner and outer experiences at the same time. So that's why we're sort of building up into this huge language. And it's kind of bleeded into the topic that I wanted to discuss a little bit about how meaning, to gain any meaning, you have to have this explosion of words. And this is a prime example of that. Like, to get to a meaningful representational tool set, we're going to have to expand it through 4 different languages to build a 5th language to build all of our different languages.
Right.
So you can see how it's a huge undertaking to say the least.
Of course, right?
And it plays right back into that whole tall order nomenclature we've been using as well.
I suppose this seems more like something that's manageable. It's not really the tall order in the sense of like a wicked problem, as you would call it.
We're standing on the shoulders of giants because the aspect-oriented stuff, the subject-oriented stuff, the type stuff, the computational stuff, all of that has been done, right? That's been done before. None of this is new. The only thing that's different is being put together, and then again, all the domain development stuff and the test development stuff, it's all been done before. Nothing. It's just a repetition of all of those things put together into a package that, is at least trying to be comprehensive in a single what do you call it? In a single shot.
Yeah, package.
So that you're not stuck kind of trying to mimic those representations within a much more limited set of tools. which is what's happening right now with general programming languages. They get you this far with all the generic stuff, but then when it comes to all of these disciplines that are sitting on top of it, it's like, okay, now adapt your code to look like, and that becomes very, very, very wordy. And while that makes sense,
so it's almost like we're pushing the responsibilities up into the higher layers, where they should be coming along integrally.
Right. And it speaks to what I just said before. It becomes very wordy, right? When you try to give it more and more meaning, it becomes longer and longer and longer to read. So part of the utility of this language in particular is to try to condense as much of that as possible into an intuitive way to express it. So that's not what stands in your way. And from building it into the actual language part, it has a kind of larger introspective power to make this how it's going to build things out. So if we talk in terms of entities and values in the domain level of the language, internally it's talking to itself in terms of aspects and subjects.
Right.
But internally under that, it's talking to itself with only types. And even further under that, it's just talking to itself in terms of values and functions.
And so this is the language stack that we were discussing last time.
Yes.
Right. And so the idea, I guess, is that at these higher layers, you don't necessarily need to know about how it's working below. However, if you want to access that functionality, you can.
Right, it's built into the same language, therefore you can weave it all together and say there's a missing computational chunk that allows the domain or the testing to work. So of course they're going to write down an algorithm in the computational realm of the language to weave it all together underneath the scenes, and then on the higher level you're just calling a high level computation to occur. And so yes, this ability to jump between layers is one of its main features. The other one is how the testing framework prevents even getting a running program until every expectation is met.
And this reminds me of that like TypeScript idea from JavaScript, right? The TypeScripting, it's like instead of the code itself, we're coming from the bottom up. You could say we're talking about the functionality that needs to happen from a higher level, like as a person would think about it. What needs to actually be happening, that's what meets the code at the bottom. So there has to be a connection.
Yeah. So to give a simple example for our programming types, it's when in JavaScript, for example, you have a function, you send it, you give it a value, and you expect the value back or some kind of error. But with TypeScript, what you can say is, for this function, I can only accept values from these set of types only. Any other type is an error. And I expect back only these set of types. So there's a mapping from one set of values to another, right? So what TypeScript is doing is it's saying it's not just a function that maps a value to a value. It is now a value that is only mapping from this set to that set.
Of types.
Right, so instead of accepting an integer, a boolean, a string, a character, any kind of type, and then failing if it doesn't work, you're setting the expectation with the type, saying, I'm only accepting ints. You send me anything but an int, fail, before you even call the function, before we even compile it. Because as it's looking at your running code, it's like you're not passing the right type into it.
That's the TypeScript stuff. Sort of,
right, that's what TypeScript adds.
But it sounds like we're also talking about something even a higher layer of abstraction, where it's like not just this better be an int, but this better be this type that's coming back as an object being returned to me at a higher level. That's kind of
so the higher level would be like how that mapping happens. So not just which set of types are mappable, but like in this context it maps this way, in that context it maps that way. That's called overriding. So that's what polymorphism
Okay,
is in
yeah.
object-oriented.
I think I just restated what you already said. I think as far as returning a type, because a type doesn't have to be an integer or a boolean. It can be like an object, a complex object itself.
Well, a type could be an integer or a boolean. Like you can have a type expression that says this type equals integer or boolean.
But can't something be returned that's say like an object with properties, like multiple properties, like it has to have an arm and a leg in order to do this, right?
The type will just define that.
Yeah.
And in our
That's what I mean, but we're talking integer boolean, that's
Yeah.
very basic. But what I'm saying is like you can have like more human readable understandings of this type as what properties it has, and that's what's allowed.
Integers and booleans are easier to understand because they're like the primitive computational types.
Yeah.
But the more abstract types that most languages also get into, like object orientation is all about that, is where you get polymorphism in the type's functionality. So for this kind of int, this calculation looks like this. For that kind of int, for example, if it's money or if it's so currency versus regular numbers. In currency, sometimes you have things like interest rates. So if you keep adding money to something, there's also another extra calculation that happens. This is a shitty example.
If you're trying to pay by money versus if you're trying to pay with a barter, then that value incoming is going to be totally considered in a different way.
Right.
Like money, you can use it anyway. The value, the barter coming in, it's like, do I need that actually?
You can have a method that says pay with,
and
then one says pay with money, one says pay with sheep, one says pay with goat, right? And so, sheep and goat is basically the same thing, but chickens.
They're not the same.
So chicken, see, the difference will be with the goat, you pay with one goat. With the chickens, you have to pay with a chicken array.
Or an egg?
Chicken array. Multiples. 10 chickens equals one goat.
Yeah.
But that's what I mean. Like you could take different types of for your calculation. But the other thing is that
right, and like a leg of lamb, or etc.
But then the flip side of that is not the object you're receiving as payment, but who's receiving as payment, the subject of the calculation, right? So that could have an effect. So some subjects can accept goats, others cannot because they're too elite or something like that. Or when they accept something, they go through a subsidiary other company or something like that to receive the object. That's where it goes. It's just with regular differences in what sounds the same. So all of that to say, we throw subjects into the mix to make that even crazier. In which these meanings can take on a completely different. So here's how I'd like to explain it then. These languages, type-based languages, they do all their polymorphism at what's called compile time. They basically say, okay, for this type, we will create a pointer that at runtime will point to the most derived type in the structure. So that way, if this method call fails on the most derived type, we'll fall back. It's a stack. It's a stack of tables that say, find this object, my function calls are at these addresses. That's all calculated at compile time for normal polymorphic languages that do things like extend the type. Right? You don't control how the stack grows and shrinks as for the selection of the code. Subject-oriented programming brings that into the fold of the programmer as well and allows you to create stacks of those at runtime. So your compile time stack is building up, and then the runtime stack adds to it. So the tree of fallbacks to call an algorithm. The key idea here is that we're trying to denote, in this context, I said I want this operation to happen. which piece of code maps that operation in this context. And so you have, do I find it in my closest context? No. Fall back to the next one. Fall back to the next one. So compile time operations create stacks like this. Subject activation does that by programmer choice and runtime. So the compiler can't even know what the actual stack would be in the final stack. It's a crazy addition to the language that it makes things interesting, let's put it that way.
Yeah. Somehow it makes me think that it's almost like two different types of languages. One which the compiler is creating these stacks, and one on runtime, which is sitting on top of what's been established.
Programmer controlled, yeah.
Right.
And what you do is you cleverly weave both together to give you the precise meaning of the code that you want.
Right.
Which makes it both easier in some sense if you're doing it right, and much tougher in another sense because it's so much more complicated. And that's again that relationship of meaning to the capacity, word quantity, if you will.
Right.
The sharpness of the meaning is directly inversely related to the quantity of words involved.
So as we were saying, the simplest things require the biggest
explanations.
Yeah. Right. And we'll be getting into that a bit later. I think.
My smokes. I can't talk without whistling anymore.
Why? Really?
Gaps in teeth.
Oh yeah.
It's fucking annoying because my tongue is used to a certain shape of the words. It's not working by trying to adjust. I can do it if I concentrate, but not if I'm talking.
Yep.
Later. We'll hit that later.
Oh, yeah. Cool. Yeah, so these languages, the APS, this stack of languages, going from the APS up into a human-readable domain language, which describes what's going on actually in the domain. And we're going to be using this to describe
in another language
the archetype stacks.
Right, which are themselves become languages. So
Right,
the uncertainty
each one.
language, for example.
So we have these different, what we've been calling offices so far.
But before that, we got to build the domain of the guild.
Right.
The guild. Is
Yeah, maybe
its
we
own
should
language.
review a little bit.
All right. I can go through the steps as soon as prompted.
Yeah, I mean, I think we can kind of dive in. Maybe try give if you can, an overview of just these 3.5 languages coming up to the point of the guild domain itself, and then we'll go from there into the offices.
Okay. So,
we're starting at the APS, and we're talking about basically cognition and how
trying to capture perception into chunks, chunking it up into so
Right.
that we can create a narrative, so that we can create a story. and all
Right.
that
So
stuff.
we're talking here about like phenomenology and how perception works internally. A model for this, anyways, that one can use to try and get a handle on like how does reality actually work? How is it constructed within my experience?
kind of
thing?
like a wordy representation of that representation. So it's like two levels of representation removed from the actual experience.
Yeah.
So we're acknowledging that.
The model we're creating or constructing here isn't the actual functioning biology itself. That would be like the terrain to the map, if you will.
Or the reality, or a reality ontology, or anything like that. No. In fact, we're just trying to figure out more like how to represent an ontology, or any ontology really, in the context of any other ontology. So to start, we need the most fundamental bits to compute with, right? Quantification. For representation to work, we need to start doing things like taking a quality, and giving it a number and a category set. Right? That's the runaway.
Like a key value, a reference to that quality.
The very same process that we call runaway. Doing that too much is runaway, but doing this specifically as a utility of a tool is what
Right.
we're trying to get to.
Yeah, and this is always it's a trope, if you will, where people will rail against representation or the spectacle and all this kind of stuff, but it's like, dude, there has to be representation.
So for computation to like actually work in its own medium, right? You have to have this jump from quality to quantity. That's where you get your computational layer from. Just different kind of computational entities that can be utilized to represent various quantities for whatever purpose. And what to do with those quantities. So this is like your C style language or JavaScript style language, where you just get the concrete computation part going. Moving from that, we get more abstract. We try to chunk.
For an example, can we like just interacting with a table? We always like to bring that one up, right? There's different functions you can pull up to do with a table.
So
right?
this is the next level, actually.
Okay.
So right now I gave you just like an ability to break down a problem into its components and then calculate something, right? So 3 plus 5, we're looking for apples, but we're looking for what's the sum of 3 plus 5. And then later somewhere we're going to like call this the number of apples.
Right. Okay. So it's like the ability to say like a quality of something resting on a surface. When you have a thing to rest, you need a surface. It's kind of like this plus that equals a surface. We're putting something on a table.
In a much more abstract sense, yes.
Right.
Like you got an aggregate
Just
object,
the
for example.
the ability to.
So a sum is an aggregate object of some numbers. So you can look at those numbers individually, or you could look at the sum aggregate of those numbers. It's the same as
Right.
It's the same as looking at the table as one of the numbers, and the object as another one of the numbers separately, and then looking at the aggregate of the object on the table as its own entity. That's the difference.
Right. This is kind of like chunking and building up hierarchies
Right.
of objects, clusters. If you
So
will.
if you'll notice, in this case, the numbers don't mean fuck all to the algorithm, but the algorithm means something to whatever's using it. There's that layering happening of where it doesn't matter on one. That's your on which things are happening, and that's your fundamental. And then the next layer up on which things that is patterning this fundamental into specific computation, x plus y. That's the layer to which it is significant. It's looking for that sum. Why it's looking for that sum? The thing that does the summing doesn't know. It has no concept of that. It's just a pattern in its
So,
medium.
I'm getting kind of